In our last lesson of this topic, we're going to take everything that we've learned about adding, subtracting, multiplying, and dividing sign numbers and apply them to word problems. When solving word problems, read the problem multiple times. Look for keywords that will help you identify the operation needed to solve the problem. Be sure to show all of your work to support your answers. If your answer is a fraction, please make sure that your answer is in simplest form. And most importantly, all answers to word problems need to include labels. Okay, you always need to put a label on your answer so that we know what your answer means. So let's take a look at our first example. We're told that Bria filled a bucket with 3/4 of a gallon of water. A few minutes later, she realized that only 7/10 of a gallon of water remained. How much water had leaked out of the bucket? Okay, so we started with a certain amount of water. A few minutes later, there was less water in there. In order to figure out how much water had leaked out of the bucket, we're going to have to set up a subtraction problem. Okay, so we're going to take the amount that we started with, which was 3/4 of a gallon, and we're going to subtract off the amount that was still in the bucket, which was 7/10 of a gallon, and this will allow us to figure out how much water had leaked out of the bucket. So this is a subtraction problem involving fractions. In order to do this, I need to get common denominators. If I have fourths and tenths, a good common denominator would be 20. So I'm going to rewrite this so that the fractions have denominators of 20. 4 times 5 is 20, so 3 times 5 is 15. 10 times 2 is 20, so 7 times 2 is 14. And now all we have to do is this subtraction problem, 15/20 minus 14/20, and that's going to give us an answer of 1/20. Okay, now we're not done yet. We need to explain what this number means, okay? So again, all answers to word problems need to include labels. 1/20 of a gallon. Remember, we were measuring our water in gallons here. 1/20 of a gallon of water leaked out of the bucket. 1/20 of a gallon of water leaked out of the bucket. In example 2, we're told that Ramon made 5 sandwiches using a half a jar of peanut butter. Each sandwich got the same amount of peanut butter. How much peanut butter did Ramon use on each sandwich? Okay, so we have to understand what we're doing here. We have a certain amount of peanut butter, and we're going to spread that peanut butter evenly amongst 5 different sandwiches. Okay, they tell us right here that each sandwich got the same amount of peanut butter. So we're going to take the amount of peanut butter that we had, which was half of a jar, and we're going to split it up or spread it evenly or divide it amongst 5 sandwiches. So let's take our half jar of peanut butter and divide it amongst the 5 sandwiches that we're making. Okay, remember with division, we want to make sure that we're working with fractions, so I'm going to put this 5/1. Okay, and then what I'm going to do is multiply by the reciprocal. This says 1/2 divided by 5. In order to do this, I'm going to keep my 1/2, and I'm going to multiply by the reciprocal of 5, which is 1/5, or 1/5. Okay, and now this is just a multiplication problem. We have 1/2 times 1/5, numerator times numerator, 1 times 1 is 1, denominator times denominator, 2 times 5 is 10. Okay, there was no way that we could simplify over here, so that's why we just multiplied, and we get 1/10. So now what does this 1/10 mean? Well, again, this was measuring the amount of peanut butter, and we were measuring it by jars. So this means that Ramon used 1/10 of a jar of peanut butter on each sandwich. Ramon used 1/10 of a jar of peanut butter on each sandwich. In example 3, we're told that Bill won 7/8 of the game of 16 games that he played. How many games did he win? Okay, so there was a total of 16 games, and Bill won 7/8 of those games. In order to find a fraction of a number, you need to use multiplication. Okay, so we're going to take 7/8 and we're going to multiply it by the 16 games. And again, we're going to make this easier if we make 16 a fraction by putting it over 1. And before I multiply, I see I can simplify. 16 and 8 have a common factor of 8. 8 goes into 8 once. 8 goes into 16 twice. And now this is 7 over 1 times 2 over 1, which is 14 over 1, or just 14. Okay, so this means that Bill won 14 games. Okay, we can show this a different way too. If I make a tape diagram. Okay, at the beginning is 0 and at the end is my 16 games. And he won 7/8 of those games. So I'm going to take my tape diagram, I'm going to break it into 8 equal parts. So I'll first cut it in half, then cut each half in half. There's 4 parts, and now cut each one of those 4 parts in half. Okay, and now there's 1, 2, 3, 4, 5, 6, 7, 8 equal parts. And again, we've got to be able to get up to 16, which means that 16 divided by 8 is 2. Each one of these must be equal to 2. Okay, and if Bill won 7/8 of his games, I'm going to take 7 of those parts. So here are the first 7 right here, 2, 4, 6, 8, 10, 12, 14. That represents the 14 games that Bill won. In example 4, we're told that the temperature at 4 p.m. was 2.5 degrees Fahrenheit. It dropped 0.75 degrees each hour for the next 4 hours. What was the temperature at 8 p.m.? Okay, so we're actually going to have a couple of different operations involved in here. We have to first figure out the total amount that the temperature is going to drop, and then we're going to have to use that amount to help us figure out the new temperature at 8 p.m. So this sentence right here says that the temperature drops 0.75 degrees each hour for the next 4 hours. Okay, since the temperature is dropping 0.75 degrees, we're going to use a negative number to represent that. Negative 0.75. All right, and it happened each hour for 4 hours. Okay, so that means I can take this number and I can multiply it by 4, which is the number of hours. So let's see if we can figure out how much that is going to be. All right, I know a negative times a positive is a negative number. And now let's just do 0.75 times 4. Okay, 5 times 4 is 20, carry your 2. 4 times 7 is 28, add 2 makes 30, carry your 3. 4 times 0 is 0, add 3 is 3. And since there are 2 decimal places here, move your decimal point in once, twice from the left, excuse me, from the right rather. And now I can see that this is equal to 3, but again, since it was a negative times a positive, my answer is going to be negative 3. So that means that the temperature is going to go down 3 degrees. So now we can take our starting temperature, which was 2.5 degrees, and we can take away those 3 degrees. 2.5 minus 3. I can rewrite this as an addition problem by keeping 2.5 and adding the opposite of 3, which is negative 3. Okay, and now I can look and see that these have different signs. My negative number has the greater absolute value, so the sign of this answer is going to be a negative number. And since they're different signs, I'll subtract the absolute values. 3 minus 2.5 is equal to a half, or 0 and 5/10. So this is going to come out to be negative 0 and 5/10. And this number right here represents the temperature. So we can say that the temperature at 8 p.m. was negative 5/10 degrees Fahrenheit. In our next example, we're going to look at a bank account. On October 19th, Mark's bank account balance was $330. Okay, this is his starting amount. So underneath the word balance in our table here, we are going to record that amount, $330. 330 and 00 hundredths. Okay. Now you're going to notice there's a series of transactions. Some of them are deposits and some of them are writing checks, which would be withdrawals. We're going to have to record these in the appropriate places and then figure out what the new balance is going to be. So on October 20th, Mark deposited $125. So here's October 20th. It was a deposit. So underneath of the deposit column, we're going to write the amount, which was $125. And since you're depositing money, that means you're adding money. So underneath of this 330 in this box right here, we're going to write plus $125. And make sure again that you line up your decimal places. And now we can add 0 and 0 is 0, 0, 0, 0, 0 and 5 is 5, 3 and 2 is 5, 3 and 1 is 4. So his balance after the deposit is $455. On October 21st, 3 checks were written. The first was check number 127 for $175.85. So here we find that, and if we write a check, it's a withdrawal. We're going to be taking out money. So it's for $175.85. And this time we're going to have to subtract $175.85. And I'm going to do my work over here to the side where I have more space. Okay, 0 minus 5 I can't do, so that 0 becomes a 10. This 0 is going to become a 9, and I'm actually borrowing from this 5, so that's going to become a 4. 10 minus 5 is 5. 9 minus 8 is 1. Decimal point. 4 minus 5 you can't do, so that becomes a 14, and this 5 becomes a 4. 14 minus 5 is 9. 4 minus 7 again you can't do, so that becomes a 14, and the 4 becomes a 3. 14 minus 7 is 7. 3 minus 1 is 2. So that makes the balance $279.15. Next was check 128 for $56.82. So we'll record that here in the withdrawal column, $56.82. And again, that means we're going to subtract $56.82. So let me show my work again off to the side. And when we subtract, 5 minus 2 is 3. 1 minus 8, that's going to become 11. That 9 is going to be an 8. 11 minus 8 is 3. Decimal. 8 minus 6 is 2. 7 minus 5 is 2. When we bring down that 2, making the balance $222.33. Finally was check 129 for $184.50. So again, that's a withdrawal. Record it in this column. And we subtract $184.50. So $222.33 minus $184.50. 3 minus 0 is 3. 3 minus 5, that 3 is going to become a 13. The 2 becomes a 1. 13 minus 5 is 8. 1 minus 4, the 1 becomes 11. 2 becomes a 1. 11 minus 4 is 7. 1 minus 8, the 1 becomes 11. The 2 becomes a 1. 11 minus 8 is 3. 1 minus 1 is 0. So that means the final balance is going to be $37.83. So that's what we can record here. Mark's final balance was $37.83. In example 6, we're told that the temperature at the beginning of a science experiment was 83.5 degrees, and during the 4.5-hour experiment, the temperature of the liquid was decreased at a constant rate until it reached 76.75 degrees. What was the rate of change in temperature each hour? Okay, so again, we have a starting temperature and an ending temperature that will help us figure out the total change. And then it happened over a 4.5-hour period, so we'll have to take the total change and divide by 4.5. So I'm going to take my starting temperature and ending temperature and subtract them. And again, one's a decimal, one's a fraction, so I converted the fraction to a decimal. And now let's go ahead and subtract. 0 minus 5, the 0 becomes a 10, and the 5 becomes a 4. 10 minus 5 is 5. 4 minus 7, that becomes a 14, and the 3 becomes a 2. 14 minus 7 is 7. 2 minus 6, that becomes a 12, and the 8 becomes a 7. 12 minus 6 is 6. So the total change in temperature was 6 7/75 degrees. So I'm going to take that amount and divide it by the 4.5 hours. So I took my decimal 6 7/75 and converted it to a mixed number 6 3/4. And now let's divide. Let's get fractions first. 6 3/4 is 27/4 divided by 4.5, which is 9/2. And now we'll multiply by the reciprocal. 27/4 times 2/9. 2 goes into 2 once and into 4 twice. 9 goes into 9 once and into 27 3 times. And so this comes out to be 3/2, or 1 1/2. So this means that the temperature decreased 1.5 degrees every hour.